Hi there. Welcome to Mathematics Alive. Our lesson for today is Mathematical Logic Lesson 2, Converse, Inverse, Contrapositive, and Biconditional. Conditional proposition or implication. The proposition if P then Q, denoted by the symbol P implies Q, is called a conditional or an implication. P is the antecedent or hypothesis, and Q is called the consequent or conclusion. Conditionals in Venn diagram form. If you look at the conditional here, there are two sets, and P is a subset of Q. So P is entirely inside the set Q, and Q is entirely inside the universal set. So we read this Venn diagram as if P, then Q, or P implies Q. Example, P is if you live in Manila, then Q is you live in the Philippines. So if you live in Manila, which is a city in the Philippines or a subset of the Philippines, then you should also live in the Philippines. So the conditional is if you live in Manila, then you live in the Philippines. Which of these related statements are logically true? If you live in the Philippines, then you live in Manila. Is that true? There are many towns and cities and places in the Philippines outside of Manila. So if you live in the Philippines, it doesn't follow that you live in Manila. So this is false. Next, if you don't live in Manila, then you don't live in the Philippines. Does that sound logical? That if you don't live in Manila, you don't live in the Philippines? This is also false. And lastly, if you don't live in the Philippines, then you don't live in Manila. This sounds logical because you cannot be in Manila if you are not in the Philippines. Converse, inverse, and contrapositive. For any conditional, there are three related statements: the converse, the inverse, and the contrapositive. So, the conditional is if P, then Q. The converse is if Q, then P. So you just switch the position of P and Q, and the inverse is if not P, then not Q. And the contrapositive is if not Q, then not P. So let's look at some examples. Number 1, conditional is if an animal has whiskers, then it is a cat. Converse, if an animal is a cat, then it has whiskers. Inverse, if an animal has no whiskers, then it is not a cat. And contrapositive, if an animal is not a cat, then it has no whiskers. We're not talking about what is true and what is not. We're just converting the conditional to the inverses, converse, and contrapositive form. Number 2, conditional is if two lines are parallel, then they do not intersect. The converse, if two lines do not intersect, then they are parallel. The inverse, if two lines are not parallel, then they intersect. And contrapositive, if two lines intersect, then they are not parallel. Now, we can form the converse, the inverse, and the contrapositive of the given conditional here. So the conditional is if it is raining, then there are clouds in the sky. And that is true. There should be clouds in the sky to enable it to rain. So the converse is if there are clouds in the sky, then it is raining, which is not true. It's false. The inverse is if it is not raining, then there are not clouds in the sky. or there are no clouds in the sky. Well, it's still false. And contrapositive, if there are no clouds in the sky, then it is not raining. Because how can it rain if there are no clouds in the sky? And the contrapositive is true. Number 2, the television set does not work is the cue if the electricity is turned off. But the sentence is in the reverse order. So the conditional must be if the electricity is turned off, then the television set does not work. Converse, if the television set does not work, then the electricity is turned off. Then the inverse is if the electricity is turned on, then the television set works. And the contrapositive is if the television set works, then the electricity is turned on. Number 3, you will not win the lottery, that's our cue, if you do not buy a lottery ticket, that's P. So we start with the if. The conditional is if you do not buy a lottery ticket, then you will not win the lottery. What is the converse? And what is the inverse? What is the contrapositive? You can pause this video and try to complete these statements so you can learn by doing. Here is the truth table for a conditional and related statements. We have the P and the Q here and the given truth values. So the conditional is P implies Q, the converse is Q implies P, the inverse is not P implies not Q, and the contrapositive is not Q implies not P. So if we look at the first set of truth values, we have P is true and Q is true, and the conditional P implies Q is true, and also the converse is true, then it follows that the inverse is true and the contrapositive is true. For this set of conditionals, we have true for every related statements, and this means that even if we switch the position of the two statements P and Q, they are still true, and this holds only for biconditional statements, meaning the statements are reversible. So for the second set, we have P is true and Q is false. The conditional P implies Q is false and the converse is true. The inverse also agrees with the converse, it's true, and the contrapositive is false. Then if the P is false and the resulting statement Q is true, then we have the conditional P implies Q is true. And the converse is false, the inverse is false, the contrapositive is also true. And lastly, if both P and Q are false, and of course, if it is false, false times false, we have the conditional P implies Q is true, converse is true, inverse is true, and contrapositive is also true. We try to look at the relationship between the conditional and the contrapositive. They agree in all cases. If the conditional P implies Q is true, then the contrapositive is also true. If the conditional P implies Q is false, then the contrapositive is also false. And observe that the converse and the inverse also agree in their truth values. So if the converse is true, the inverse is true. If the converse is false, the inverse is also false. So we call these statements equivalent statements. A conditional statement and its contrapositive are logically equivalent. The converse and the inverse of a conditional statement are logically equivalent also. The conditional statement and the contrapositive must agree with each other, and they must both be true or they must both be false. Similarly, the converse and the inverse must agree with each other. They must both be true or they must both be false. Biconditional. A biconditional is a statement of the form P implies Q and Q implies P. So if you join this together, then we have P implies Q and Q implies P, or P if and only if Q. P implies Q can be read as P is sufficient for Q. Q implies P can be read as P is necessary for Q. So the biconditional P if and only if Q can be read as P is necessary and sufficient for Q. A biconditional combines a conditional and its converse into one statement. Every definition is a biconditional. Let's look at this definition of two angles which are congruent. The conditional is, if two angles are congruent, then they have the same measure. The converse, if two angles have the same measure, then they are congruent. So since this is a definition, the converse and the conditional are both true. And so the biconditional is two angles are congruent if and only if they have the same measures. This is the truth table for a biconditional. So let's look at the implication. P implies Q. If P and Q are both true, the implication P implies Q is true. And since it is a biconditional, then Q implies P is also true, and the biconditional is true. But if the conditional is starts with a P which is true, Q is false, then P implies Q is false, and Q implies P is true and the biconditional is false. Likewise, if the P is false and Q is true, then also the biconditional becomes false. But if both P and Q are false, then the biconditional becomes true. Now we can also represent the biconditional with a Venn diagram. So in this Venn diagram, the set P and the set Q are equal. So they are overlapping sets or simply the same set. So we have P implies Q and Q implies P represented by this one circle. The P here is a quadrilateral is a square, and the Q, a quadrilateral, has 4 equal sides and 4 right angles. So the conditional is, if a quadrilateral is a square, then it has 4 equal sides and 4 right angles. The converse, if a quadrilateral has 4 equal sides and 4 right angles, then it is a square, and that's still true. And the inverse, if a quadrilateral is not a square, then it does not have 4 equal sides and 4 right angles. And the contrapositive, if a quadrilateral does not have 4 equal sides and 4 right angles, then it is not a square. And these are all true statements. In my next video, I will be discussing symbolic arguments. In this lesson, you will be able to determine the validity or falsity of an argument. Please don't forget to like, share, and subscribe to this channel by clicking the button below. Thanks for watching and bye-bye!